Hey everyone, welcome back to the channel. Today we're diving into the world of building efficient retrieval augmented generation, or RAG, applications. If you're into AI, large language models, or just want to level up your app development game, this is for you. We're breaking down a complex topic into bite-sized, practical insights, so stick with me as we explore how to make robust AI apps using frameworks like LangChain, LlamaIndex, and SingleStore. Let's get started. First off, building AI applications isn't just about slapping a large language model like GPT into your code and calling it a day. It's a multifaceted process. You've got data collection, pre-processing, feature engineering, model training, hyperparameter tuning, evaluation, deployment, and ongoing monitoring. Each step demands expertise and precision. Think of it like building a high-performance car. Every component needs to work perfectly together. Now, LLMs are powerful, but they're not enough on their own. They've got limitations. For one, they have a knowledge cutoff based on their training data, so they can't access real-time info. They can also hallucinate, generating false information that sounds convincing, but isn't true. Plus, they struggle with private or proprietary data, and have limited context windows, meaning they can only handle so much info at once. So how do we fix this? That's where frameworks and RAG come in. Let's talk about why LLMs alone don't cut it for robust apps. You need a data management layer to handle various sources and storage, infrastructure for reliability and scalability, and integration capabilities to connect with external systems. Imagine trying to build a chatbot that only knows what it learned up to December 2023. It's not going to answer questions about today's news or your company's internal data. That's the problem we're solving. Enter LLM frameworks like LangChain and LlamaIndex. These are game changers for building data-responsive AI apps. LangChain, launched by Harrison Chase in 2022, is an open-source platform that simplifies chaining together components into workflows. The Lang part stands for language models, and chain refers to combining LLMs with tools like prompt templates, memory, agents, and indexes. LangChain's core principles are data awareness, accessing enterprise or open-source datasets, and agentic behavior, meaning it can interact with tools like search engines or calculators to deliver rich functionality. LangChain's components are super flexible. You can use any LLM, open or closed source. Prompt templates let you customize inputs for different scenarios. Chains combine LLMs with modules to execute sequences of tasks. Indexes handle document loading, text splitting, vector storage, and retrieval. Agents use LLMs for reasoning and decision-making, while memory keeps track of conversation history for context-aware responses. Use cases? Think question answering, document summarization, or even code generation. LlamaIndex, on the other hand, shines at efficient data indexing and retrieval. It's designed to make your LLM apps contextually aware by connecting them to external data sources. Together, LangChain and LlamaIndex can handle complex workflows and retrieval tasks, especially when paired with a powerful data platform like SingleStore. Now let's get to the star of the show, Retrieval Augmented Generation, or RAG. RAG is a technique that enhances LLMs by fetching relevant external data before generating responses. It's like giving your LLM a library to reference instead of relying solely on its memory. This solves the knowledge cutoff and hallucination issues, making your app more accurate and up-to-date. So how do you build a RAG app? You need a few key pieces. First, a vector database to store and retrieve data efficiently. SingleStore is a great choice here. It handles SQL, JSON, full text, and vector workloads all in one platform, scaling from one user to 1 million. Second, you need frameworks like LangChain or LlamaIndex to manage the retrieval and generation process. LangChain is ideal for advanced workflows involving agents and memory, while LlamaIndex excels at data indexing and retrieval. If you need both, you can combine them for maximum power. Let's talk optimization. Building an efficient RAG app requires fine-tuning several components. Chunking strategy is critical. Semantic chunking, where you split text based on meaning, outperforms fixed-size chunks for complex documents. Retrieval methods matter too. Experiment with the number of retrieved items, re-ranking, or hybrid search to boost relevance. Embedding models should be domain-specific for better accuracy, but balance quality with cost and latency. Prompt engineering is another big one. Structure your prompts with clear instructions and separate context from questions. Finally, caching embeddings, retrieval results, and LLM responses can slash costs and improve performance. What if you skip frameworks? You'd have to build everything from scratch: API authentication, rate limiting, error handling, prompt templating, context management, and more. It's like reinventing the wheel. Frameworks like LangChain and LlamaIndex abstract away this complexity, letting you focus on building features, not plumbing. SingleStore ties it all together as an all-in-one data platform. It ingests and indexes documents, supports similarity matching, stores user events, and handles vector workloads. Tutorials for RAG with LangChain and LlamaIndex on SingleStore are available online. Check out the GitHub repos for hands-on guides. You'll need a SingleStore account and an OpenAI API key to follow along. So, how do you choose between LangChain and LlamaIndex? If your app needs advanced workflows, chaining, or memory management, go with LangChain. If efficient data retrieval is your priority, LlamaIndex is your pick. For complex apps with both requirements, use them together. SingleStore's unified platform makes integration a breeze. That's the rundown on building efficient RAG applications. It's all about combining LLMs with frameworks and data platforms to create robust, accurate, and scalable AI apps. If you found this helpful, drop a like, subscribe, and let me know in the comments what AI topic you want to explore next. Until then, keep coding and stay curious. Thanks for watching.